PreCalc, PreCalc, PreCalc. Today is 126, so you're watching this after Thursday's lesson, and once we have Friday off, you may watch it Friday, Saturday, or Sunday. I'll put the title in a minute, but right now I want you to write down this definition. The set of all points x, y in a plane, the sum of whose distance from two fixed points called foci is constant. Alright, so let's make some sense out of nonsense here. And here's what this means. So say I have two fixed points. They're called foci. And one focus, two focus, first focus, second focus, two foci. Alright, now I am looking at a point, I'll call it here. That's has an x and y coordinate, but just being general, I'm just going to put a x there. And that x point is the same distance from this point as it is from this point. So I can call this distance 1 and this distance 2. And so we know that in this definition we can find that the sum of the distances, so sum d1 plus d2 is a constant. So let us see where is there another point that meets that requirement. So I'm going to keep d1 plus d2 are going to add up to the same, but what if d1 gets bigger, d2 gets smaller, and it still equals k? Well, that happens, say, right here. So let me get rid of this d1 and this d2 so we can unclutter this. So now we have distance 1, which was over here, is now longer, and now distance 2, which was here, is here, and it's smaller in such a way that d1 plus d2 is still the same number, constant. So we have 2 points. And maybe there's a point over here where distance 1, which is now way longer, and distance 2 is way shorter, but it still equals some constant number. And if we go all around and get all of the points x, y in the plane that meets that requirement, we get a shape that looks like that. Alright. In math class, we call it the ellipse. Now, the oval is the same thing, but it's not the mathematical term. Alright, so the ellipse and the set of all points, we could have said the locus of all points. So remember, the word locus means location. So this is a locus definition. And I also want to point out that it's a conic section. So back to our cone on an inverted cone. We see this all the time. A cone balanced on an inverted cone. Alright, and it turns out if the plane comes in, and when we did the parabola, it sliced just the piece up here. But if it cuts in an angle, it's a little deeper. Say the plane is slanted like it was last time. And can you envision when we look down inside of this cone with our eyes, we are going to see that the intersection between that cone and that sharp plane or piece of paper actually will intersect an oval. Alright, my drawing's not so great, but it does. So it's another one of the conic sections. So far we've had a circle when the plane cut this way, we've had a parabola when it cut this way, and now we have the ellipse when it cuts that way. Alright, every figure has its own terms, so let's introduce you to the terms. So I'm going to put a coordinate plane here. Let's say the ellipse has a focus here and a focus here. So the ellipse will go around like that. Alright, when the focus, the two foci are together and they're on a line, we're going to draw that line. That line is called the major axis. 2 points on the major axis at the extreme points are called vertex. A vertex and a vertex. Here a vertex, there a vertex. Vertices are what they're called. And if we cut the ellipse in half between the two, this is a focus and this is a focus. There are two. When you cut the ellipse in half between the two focus, you've drawn the minor axis. And what else do we need to know about this? Alright, the only other thing is there are some distances, and it turns out the distance from here to here, so I'll draw it like that, is called A, and from here to here is called B. This ellipse is a horizontal one. So now let's look at the other way it could go. Put it over here. So say the foci were like that. So then the ellipse would be a vertical one. And the major axis, which connects the two foci, would be here. The one that cuts right in half between the two foci is the minor. The vertices, extreme points on the major axis. A vertex here, a vertex there, a focus here, and a focus there. Now this is called A. So A is always on the major axis between the center. I'll call this, that's what I forgot, the center. So let's scoot back over here and put in the center. Center is not on the ellipse, it's the intersection of the major and minor axis. Now we have a center, foci, vertices, major, minor, A, and this is B. So B is the part from the center to the extreme point on the minor axis. Alright. So do you have that all smushed in? And this one is a vertical ellipse. Alright, standard form. Stand up, so I can give you standard form. Okay, be seated. We have x minus h quantity squared plus y minus k quantity squared. That looks familiar. It looks like the circle, except I haven't completed it. There's a value called a squared and b squared, and that all equals the magic number 1. So this is in standard form, and that is for the horizontal ellipse. And the way I remember that, A and B, recall A is always longer than B. So when we looked at A here, it's longer than B. When we looked at A here, it's longer than B. So A is always longer. So I wrote A is greater than B. So A squared when a, the larger one, is under the x squared term, it's a horizontal. When a squared is under the y squared term, it's a vertical. So let's show you that one, standard form for that. I'll write the tops the same, and the 1 the same. It's just that the a squared and the b squared are going to switch. Now the larger one, a, is under the y squared term, and this is a vertical ellipse. All right, so let us go ahead and do a problem, and we'll be done. All right, so similar to what we've seen, we start with general form. And this one happens to have this equation in general form. 4x squared plus y squared minus 8x plus 4y minus 8 equals 0. So I gather my x terms together, and I gather my y terms together, just like the circle so far, and I'll move the constant to the other side. All right, now I would like to complete the square, and I can do that straight off right here, but right here I cannot because of this 4. The lead coefficient for the squared term has to be 1 before you can complete the square. So we're going to have to pull that 4 out of the parentheses, and that leaves this behind. And this one doesn't have that problem. So now I go in and complete the square here. So half of 2 is 1, squared is 1. Now it looks like I added a 1, but it's a 1 in disguise. It's really connected to this 4. So where it looked like I added a 1, I really added a 4. 4 times 1. So I go out here and balance the scales by adding 4. Then this, completing the square here, half of 4 is 2. 2 squared is 4. I add a 4. All right, so this side is 16. Now I complete the square. X minus 1, that's the perfect square created there. Y plus 2 quantity squared here. So I'm still not in standard form because I need a 1, and I'm not sure which this is going to be, but I need a 1. I have a 16 in that spot. So I'm going to divide by 16 each term to get the 1 that I need. So this is 1. This 4 and this 16 is like a fraction. 4 over 16 reduces to 1 over 4. And y plus 2 squared over 16 equals 1. All right, now it is completely in standard form. So is this a horizontal or a vertical from what we said? Well, the larger term is a squared, so this is my b squared, this is my a squared. When a squared falls under the y term, it is a vertical. So I'm going to draw my coordinate plane. This time, h and k, I don't think I told you this, but the center, right here, when I mentioned the center, that is hk. Over here, the center is hk. All right, little details. All right, so hk, the center, is the opposite of this, the opposite of that, so we get 1 minus 2. So I'm going to go over here on my sketch, go over 1, down minus 2. That's the center. All right, since this is my b squared, this is my a squared, I need to know a and b. The square root of that is a, and the square root of that is b. So we have an a of 4 and a b of 2. So from the center, I'm going to go up 4 and down 4. Alright, that gives me my vertices on the major axis. And then on the y, going this way, I go the b over 2 in both directions. 1, 2, 1, 2. Because looking back here, that's what A and B do. So here, remember from the center we went up A and down A, over B and over B. So I'm taking the same sort of pattern there. Went up A, which was 4, down 4, over 2, down over to the right 2, and to the left 2. So that's enough to get a rough sketch of the ellipse. It's a vertical one, and I can come up with these points should I be asked to. Alright, so that's an example of how you graph an ellipse from standard form. Alright, I hope you found that enjoyable. I found it very refreshing. Alright, take that refreshment through till Monday morning, where we'll be refreshed further. See you then.